Good morning to all. Today we'll be discussing about second part of the thin cylinders topic, which is a part of theory of structures. So what we have learned in the previous class, once we'll revise that. So in the previous class you have learned that if small t, that is thickness of the cylinder, is less than or equals to 20 times of d, actually it should be 20 times of d, it is known as a thin cylinder. And in the same manner, if t is greater than 20 times of d, that is diameter of the cylinder, it is known as thick cylinder. And what all we have studied in the previous class is what is meant by a Hooft stress and how we can calculate the Hooft stress. We have derived an equation which is P into D by 2 times of thickness of the cylinder. So in the same manner, we have derived an equation for longitudinal stress also, that we have got as P into D by 4 times of T. So these things we have covered in the previous class. In this class we'll be discussing about the application of this formulae and how we can calculate the Hooft stress and longitudinal stress in the form of numericals. We'll see. So in this tutorial we have the following objectives to be achieved. So on completion of this period or tutorial, you would be able to know what is meant by maximum shear stress and how to calculate the hoop, and hoop is nothing but circumferential stress or hoop stress, and longitudinal stresses. After that, we'll just have an introduction to the various types of strains which will be developing in the cylinder. So if we go into the topic, initially what is meant by maximum shear stress, or simply shear stress? There will be an development of shear stress because of the hoop stress and longitudinal stress. So at any point on the circumference of the cylindrical shell, the longitudinal and hoop stresses are orthogonal. This thing we have seen in the previous tutorial, that longitudinal and hoop stresses will be developing in orthogonal direction, that is in perpendicular directions. Because of these stresses, there will be a new stress will be developing called shear stress. So due to presence of longitudinal stress and hoop stress, there is shear stress developed in the cylinder. So because of this longitudinal and hoop stress, there is a new stress which is getting developed, which we call it as shear stress. Generally it is denoted by symbol tau. So we'll see how we can calculate and what will be the equation for this shear stress. So maximum in plane shear stress is given by tau max. This will be T max, or generally we can write as tau max. Tau max equals to sigma h, that is hoop stress, minus sigma L whole thing divided by 2. So you can write like this: sigma h minus sigma L whole thing divided by 2. And if we substitute sigma h and sigma L values, we'll get the following equation: PD by 40 by 2, and if you take the LCM, you get 4 into 2 times of T, which is PD by 8T, which we got here. So generally we can calculate maximum shear stress in a given plane of a thin cylinder by using a value or an equation which is P into D by 8T. So in the same way, if we can compare hoop stress and maximum shear stress or longitudinal stress to the shear stress, we can get an ratio. So sigma h by tau max equals to PD by 2T by PD by 8T. So after cancellations, ultimately we'll get ratio as 4. So the ratio of hoop stress to the maximum shear stress is 4. So this thing can be helpful in some of the numericals or in objective type of questions. So this thing you have to remember. So if we go into the numericals, which are based upon the hoop stress and longitudinal stresses, we'll solve some simple basic numericals which include hoop stress formula and longitudinal stress formula. So a cylindrical shell of 2 meter diameter and 20 mm thick. So if you write the given data, small d equals to 2 meter and thickness is given as 20 mm, is subjected to an internal pressure. So our capital P or small p, whichever you consider, is given as 3 Newton per mm square. So better to convert whole things into mm, or we can convert these two values into meter. So instead of converting two values into meter, it is easy to convert one value into mm. So d is equals to 2000 mm, right. So units are very important. If the units go wrong, everything will be gone wrong and we'll get finally an wrong answer. Find the circumferential and longitudinal stresses developed in the material of the cylinder. Okay, so what we need to find? Sigma h or fh. We can denote as sigma h or fh. In the same way, longitudinal stress sigma l or f suffix l. So these things we need to find out. So the given data is diameter 2 meters, nothing but 2000 mm, thickness is 30 mm, 20 mm, and internal pressure is 3 Newton per mm square. So sigma fh or fh, we have equation of P into D by 2 times of T. So P is 3 and D is 2000 divided by 2 times of T. So ultimately we can get the value of 150 Newton per mm square. So in the same manner we can calculate axial or longitudinal stress, because we have already found out the equation for both the stresses. Sigma L and FL equals to PD by 40. So same values P and D by 4 times of T here. So as denominator increased by 2 times, the whole value will get by reduced by 2 times. So that is 150 by 2, 75 Newton per mm square. So this is the basic form method or basic numerical which is based on calculations of hoop and longitudinal stresses. So if we go into the next numerical, is there any difference in this? Once you may read the question and find what are the differences, or is there any difference in this, or the same numerical is of same category. So if you observe the previous question and this question, it is of similar category. I have just made the same type of problem so that you'll get used to it very easily. A water main of 1.5 meter diameter and 20 mm thick. So small d is 1.5 meter. It can be written as 1500 mm, and thickness is 20 mm. and thickness is 20 mm. Is subjected to an internal pressure of 1.5 Newton per mm square. Okay. So in the same manner as the previous question, we need to calculate the circumferential or longitudinal stress. In some cases they may ask calculate the hoop stress. So just a terminology difference, as circumferential and hoop stress both are one and the same. So you should not get confused with this. Induced in the pipe. So we need to calculate sigma h or fh and sigma l or fl. So the given data is diameter of the main pipe is 1.5 meter or 1500 mm. Thickness of water main, that is nothing but pipe, it is 20 mm, and internal pressure is 1.5 Newton per mm square. So we have the formula of PD by 2T for circumferential stress. P we have 1.5 and D 1500 divided by 2 times of small t. Small t is 20. If we calculate, it comes as 56.25 Newton per mm square. So in the same manner, if we calculate the longitudinal stress, sigma L or FL is equals to PD by 4 times of T. So P is 1.5 and D is 1500 divided by 4 times of T. T is 20. So 56.25 divided by 2 will get us 28.125. So in this way we can calculate basic hoop stresses or longitudinal stresses in a cylinder. So in the next problem on numerical, there is a slight change in the given data, so nothing to be worried with this data, or nothing to get confused. It is same as previous problem only, but the way they have produced the values is bit tricky. If you read the question nicely, then you can solve the problem easily. So if you go into the question, a steel penstock of 1 meter diameter and 10 mm thick is subjected to 100 meter head of water, right? So what is the given data here? 1 meter diameter of the penstock. What is meant by penstock? Penstock is a kind of pipe, huge pipe, which is used for diverting of water from upstream to downstream in hydroelectric power plants. Okay. So small t is 10 mm thick right. Now we need to calculate the hoop stress only at the bottom of the penstock. Given P equals to small w into h. So here P is internal pressure. So instead of giving internal pressure value directly, he has given certain equation to calculate the internal pressure. So if we observe this small w value which he has given 9.81 kilonewton per meter cube. So it is the specific weight times of head of water. So specific weight times of head of water. H is the head of water. That is why he has mentioned 100 meters head. This will be useful for our calculation of P value. So if we see this, W is 9.81 times of H. So here we have this, we need to look at the units carefully here, because diameter it is in 1 meter, in the meters I mean, and thickness is in mm, and head of water is in 100 meter. So instead of converting everything into mm, it is easy for us to convert mm into meter, because we have W value in terms of meter cube. So keep it as 1 meter only instead of converting into 1000 mm, and instead we need to convert this thickness into meter. So 10 mm is equals to 100, 0.01 meter. So if we solve this, diameter is given as 1 meter, and here I have converted everything into mm. It's your choice. If you want to convert into mm, it is well and good, or if you want to substitute into meter only, that is also correct. Nothing is wrong, but the only problem is if you convert some units and if you leave off another units, that will be a problem, because the whole answer will be ultimately wrong. So better you convert everything into mm or convert everything into meters. So thickness of pipe is mentioned as 10 mm, right, and head of water is 100 meter. So like I have mentioned, P is equals to W into H, 9.81. If you observe this W value, it is given as 9.81. That value will be having for water. So 9.81 into 100 will get as 981 kilonewton per meter square, right? So if we convert this meter square into mm square, so 10 power 6 goes to upside, just like this, 10 power 6 mm square. and here we have kilo. Kilo is nothing but 10 cube. So ultimately getting like this, and 9.81 minus 3 or 0.981. So kilo is gone and Newton per mm square. So like that we have got this value 0.981 Newton per square. So now we got the p value and we have d value, we have small t value. With this we can calculate the hoop stress. He has asked only hoop stress. Hoop stress is again P into D by 2 times of T. So what is P? 0.981 into 1000 diameter by 2 times of T, nothing but 10. So here we'll get a value of 49.05 Newton per square. So hoop stress at the bottom of the penstock is 49.05. So here we need to observe one more thing. He has given us at the bottom of the penstock. So generally there will be a distribution of stress like this, means at bottom maximum value, triangular distribution, at the top it is a 0. Generally it will be having like this for water. So as the bottom, at bottom we have maximum value, that is W into H. He is asking us to calculate at the bottom. If we mention to calculate, if we ask us to calculate at some other point on the penstock, he has to give what is the shape of this distribution, pressure distribution diagram. So he has to mention in the question itself whether it is having a linear distribution, from uniform distribution from 0 to 0 at the top to, or reverse, vice versa, anything. It can be like this or like this based upon the position of the pipe. So he has to mention the pressure distribution diagram. In some cases it may be like this, parabolic. So in parabolic, at middle point we'll be having maximum value. So he directly mentioned here, he has mentioned at the bottom, and he has given P is equals to WH. That is why we are not getting any confusion here. If he mentions that calculate at some other point, either at the centroid or middle of the pipe, if he mentions like that, he has to give the pressure distribution diagram also, the shape of the pressure distribution diagram. So we got hoop stress at the bottom of the penstock as 49.05 Newton per square. The units are very much important. See, if you substitute directly this 1 meter and rest are all in meter mm, you won't get this value. You will be getting some other value in decimals. So these are the basic numericals based on types of hoop stresses, means types of stresses, that is hoop stress, longitudinal stress in a cylinder, and how we can calculate these type of stresses. We have seen in 3 numericals till now. I hope you are familiar with those things, because those are the basic things you need to understand before going into the next topics. So here our next topic is strains in thin cylinders. So I want to ask a question here, whether strains are dependent quantities or stresses are dependent quantities. I mean to say, whether this thing is depend on this or this thing is depend on this. If you know the stress strain curve of the mild steel or concrete, anything, you will be knowing this answer. So I hope you will be searching for this. If you know this thing, it is well and good, or else make sure what is what. So till now we have discussed about the stresses only in thin cylinders, and now we are getting into strains part. So generally strain can be written as change in dimension by original dimension, and it is denoted by epsilon. So it can be length, or it can be any dimension. It can be length, breadth, or height. So change in dimension by original dimension, and it doesn't have any units. So these are the basic things we need to know. I hope everybody knows this. So strains are of 3 types again. As I have mentioned, stresses are also of 3 types. I hope you remember them. One is circumferential stress, second one is longitudinal stress, and third one is radial stress. And in assumptions I have mentioned that radial stresses we will neglect them, as in thin cylinders, as they will be having negligible value, we'll consider sigma r, nothing but radial stresses is equals to 0. So in the same manner, here we have strains are of 3 types. Those are longitudinal strain, circumferential strain, and volumetric strain. So if you remember what I taught in the previous class, hoop stress will be having a nature of tensile nature. So it will try to increase the diameter of the cylinder. So D can become D plus delta D. So this is the increased part of the diameter. So because of hoop stress, there will be an change in diameter. So generally there will be an increase in the diameter. In the same manner, in case of longitudinal stress, length gets increased, right? So L becomes L plus delta L. So because of these two stresses, you can see the dimensions of the cylinder are getting increased, that is diameter wise and length wise. So if diameter gets increased, area gets increased, right? Because area is pi d square by 4. If d is increasing, total area gets increased. In the same manner, length is getting increased. So what is now volume of the cylinder? Area into height or length. So in this, what are the changes here? Because of hoop stress, diameter is getting increased and length is getting increased. So as there is a change in both the values, there will be a change in volume also. That's what I mean. I'm trying to explain it. So because of these longitudinal and shear strains, there will be a strain in volume also, which is known as volumetric strain. So generally we'll denote them as longitudinal stress as epsilon L, circumferential strain or hoop strain as epsilon H, and volumetric strain as epsilon V. I hope this concept is clear to everyone. Because of hoop stresses, simple, because of hoop stresses, diameter gets increased. Because of longitudinal stresses, length gets increased. As these two are getting increased and these two values are involved in calculation of volume will also get increased. So that particular increase in volume or increase in value of the volume we can calculate by forming an equation or deriving an equation for volumetric strain. So I hope this is just an introduction to the types of strains. In the next class, we'll form an equation or we'll derive an equation for all these types of strains, and further we can solve some numericals also. So before concluding, we'll just observe the gist of this tutorial, summary. So in this class, you have learnt about how to calculate the maximum shear stress, that is tau max if you remember, it has a equation of like this, which is equals to PD by 8 times of T. So maximum shear stress is equals to PD by 8T. Now, and what are the next things we have discussed? We have solved some numericals based on types of stresses, that is sigma H and sigma L. We have found. We have solved 3 different numericals. I hope that concept is clear to you. And next is, I have given just introduction to the type of strains, and I have mentioned there are 3 types of strains, which is longitudinal strain epsilon L, circumferential or hoop strain, and volumetric strain. And also I mentioned how this volume gets increased. I've just given an introduction. In this class I'll explain it in detail. So I hope you revise these things and you will be ready for the next future topics. So with this I want to conclude this tutorial, and I hope you can solve some more numericals based on calculation of stresses. If you find anywhere in your textbooks or in any competitive exam papers, try to solve those things, and first of all read the question nicely so that half of the numerical will get solved by understanding the question itself. So another most important thing is, while solving the numerical, focus on the units which he have mentioned and how you substitute those units in your solution. So with this I want to conclude this tutorial and see you in next class. Thank you.